Algebra 1/2. Greetings, Caleb. I am going to talk to you right now about Lesson 73. The topic is right circular cylinders. A cylinder is a three-dimensional object whose base is a circle. The sides are perfectly straight or at a right angle. And this is best expressed in real life by one of those big cardboard containers of oatmeal. If you know what I'm talking about, there's a little string here, you rip it off, the lid comes off, but it's perfectly smooth, perfectly straight. A can of soup or baked beans or something is close, but they have sort of a little indentation, don't they? And they have a little lip around here. So they're not a perfect right circular cylinder, but you get the idea. It's round on the bottom, round on the top. This side comes in at a right angle. Okay, the volume of a right circular cylinder is the same formula we use for all area of the base, and we multiply it by the height. So in this case, we have a circle for a base, and we don't even have an example in this problem. It's crazy. Well, we'll just work with what we've got here. We've got a circle with a radius of 2. So, to find the area of the base, we say, it's a circle, right? This is kind of drawn a little bit to look like a three-dimensional thing, although it's not a very good drawing, I have to say. But if we look straight into the bottom of this, we would see a perfect circle. We find the area of that base by remembering that the area of a circle is pi r squared. If you don't have that memorized, please, by all means, memorize it. So in this case, it would be 4 pi, because our radius is 2, so we square it, and we get 4 pi. Then we multiply that, so that's the area of the base, and then we multiply it by the height, which we see in the picture is 20. So the volume of this entire creature is 80 pi, right? This 4 times 20 gives us 80. And then if we multiply, remembering that pi equals 3.14, we can do 3.14 times 80. Notice this is a little trick you can use. Let the 0 hang off. Just copy it down, and now you can do the rest of the problem without having that 0 interfere. 8 times 4 is 32. 8 times 1 is 8, plus 3 is 11. 24, 25. And we need to put 2 places behind a decimal. So, and let's see, what are our units? They are meters. This is a really big cylinder. And it's volume, so it's three-dimensional. That is the size of our right circular cylinder. It's the volume of our right circular cylinder. I'm just going to write V equals. It's a three-dimensional unit because it's a three-dimensional shape. So, this same formula will be used for any size shape, or any type of shape that we use, but it works for a right circular cylinder just fine. Okay, what if we want to find the surface area? Let me just make it clear. This part is volume, and then we're going to do surface area. Surface area, remember, is like wrapping it like a gift. We're not measuring the inside, how much you can fill it up, but we're measuring the outside. How much wrapping paper would you need? Perfect seamless wrapping paper would you need to cover it? So in this case, you know what box cutters are, I'm quite sure. Take the box cutters to your imaginary oatmeal cylinder and first carve off the top, then carve off the bottom. Then we'll have the and like call to your dog and freak it out, stuff like that. But what I want you to do, take your box cutters and cut straight down along the cardboard circular part and lay it out flat. We're going to have to imagine that this is a cool kind of cardboard that when you lay it flat, it doesn't try to curl back up. And this is the body of the container laid flat. So when we cut it apart, we get these three flat surfaces, and now we can measure each of these and get the total surface area. So these circles, we already know, they have a radius of 2, and this is 20 inches tall. Not to scale, Caleb, work with me. So the area of the circles, well, we already calculated that. We know it's pi r squared, and we know that that would be 2 squared times pi, I'll write it out this time, which is 4 pi, but that's just for one of them. Before we only needed to measure the area of the base. Now we've got 2 that we have to account for, so I'm going to add a second 4 pi for the second one. So that's the area of one circle, that's the area of the other circle. Now we need to find the area of the big rectangle. Not to scale, sorry. That was a really weird looking rectangle compared to that. How do we find the dimensions of this? We need to know the length and we need to know the width of this rectangle. Well, we know right here that the width is 20, but what is this distance here? How can we find that? Well, if you can imagine it back again, this cardboard used to be wrapped around that circle, right? We cut the circle off, and when we looked inside of it, this was the edge that we saw. It was curled up at the time. We've taken it and flattened it out, but this should be equal to the circumference of the circle, which is pi 2r, right? Pi times the diameter, or pi times 2 times the radius, same difference. So this would be equal to 2 times the radius, which is, again, 4 pi. Last time we squared multiplied it by 2, it works out to be the same number. So we're taking this 4 pi that is the length and we're multiplying it by the width, which is 20. So that gives us 20 times 4, that gives us 80 pi as the area of that whole thing. Sorry, I'm looking at my answer. Okay, 4 pi for the length, 20 for the width, that gives us 80 pi. Now we add these up and we get 88 pi. Okay, I'm going to flip. We're going to take 88 pi and we're going to, I got myself crooked there. We're going to take 88 and multiply it by 3.14. I'm going to do it big. 8 times 4, 32. 3. 8 times 1 is 8, plus 3 is 11. Oh, if only you were here to add for me. 24, 25. Okay? And we know that this is going to be the same. It's just going to line up differently. 2, 5, 1, 2, 2, 3, 6, 7, 2, and I'm just looking, why is that not? Oh, I know why. Okay, and so that is our unit, which happens to be what? Meters again. Meters squared. That is our final answer. of the surface area, which again is the area of the top circle, the area of the bottom circle, and then the area of that middle rectangle. This does not match to what's in the book because John changed his picture, and his radius that he used for this was actually 3. So our numbers are slightly different, but our process is exactly right. Okay, this is the part I care the least about. What I care the most about is that you get these answers. 4 pi for the top circle, 4 pi for the bottom circle, 80 pi for the rectangle, for a total of 88 pi. This is the answer that I'm looking for. In the answers, John usually gives the pi answer, with the answer with pi in it, and then he calculates it out multiplying. I don't really care that much about this. Anyone with a calculator can multiply their answer by 3.14. This is the important part. All right, I will see you soon for lesson 34.